Okay, so now this next question, they were nice and they gave us 2 of the roots, okay? And they want us to be able to solve the rest of it. Like, we've never been able to solve this. This is a 4th degree polynomial. This does not factor. You can try and group this all day long. Group 2s, group 3s, group whatever you want. It's not going to factor. So the fact that they gave you 2 solutions, very nice of them. You're going to just do synthetic division. And what you're going to do is synthetic division first for the x equals 3, and then you're going to do synthetic division again for the other one. Okay, so watch this. Let's start with 3. Well, synthetic division. 1, 2, negative 4, negative 20, negative 12. Just kidding. Negative, what did I do wrong?
Oh, you said negative 4. Yeah.
Don't listen to what I'm saying. Just listen to what I'm doing. I said negative 4, and I wrote negative 7. That's weird. Oh, sorry. Must be the lack of sleep. All right, so we're good? That's the right one, right? 1, 2, negative 7, negative 20, negative 12. All right, synthetic division, go. You guys are fast at this. 3, 5, 15. Oh, look, remainder 0. We knew it was going to be a remainder 0. They told us it was a solution. So I'm supposed to have a remainder of 0. Okay, so that makes sense. Now, what you can do is instead of writing this out with x's and blah, 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 stop right here and do synthetic division again with this remaining one. If it was a factor of the original one, it'll be a factor of this one as well. Okay? So now what's my new, my other root was negative 2. So now I'll put a negative 2 here. Okay.
Well, you get a different answer.
What do you mean? Like if from what?
Well, like if you start with negative 2 to the original.
You'll still get the same answer. It's just more
faster
work.
this way.
Yep, this is just quicker because you've got less numbers here to deal with.
Yeah.
You only got 4 numbers now instead of 5. Okay, and what, yeah. So I would always just kind of do it this way if you're given more than one root. Just kind of just keep going with your answer with that quotient and just go from there. Good question. Minus 4. Oh, look, remainder of 0. We knew it was going to be a remainder of 0. It's a factor. Okay, and then now I'm left with x squared. Does this guy factor?
Yeah.
X squared plus 3x plus 2? It's our lucky day. All right, that one does factor. And so what are our last 2 solutions here? Negative 2 and negative 1. So when it says solve, you want to list all solutions. Okay, they had already given us x equals 3. Then they also gave us x equals negative 2. We found another x equals negative 2. And we found an x equals negative 1. Yeah. All right, let me come look at it. I'll see what happened. Okay. So when I do this now, right, these 2 are the same. So this will be like a double root in here. You don't have to write it twice. What you could do is list it once, but just write multiplicity of 2. Okay, instead of writing it again. How many total solutions did I get?
4.
4. What was the degree of my original equation?
4.
4. Look at that, right? Degree is always your highest exponent. So you'll get an idea of about how many solutions you should have. Fundamental theorem of algebra says that you have to have at most 4 solutions if the degree is 4. So I could have less, right? But at most there should be 4, and that can be a combination of complex, real, imaginary, normal ones, right? It could be all of them involved in there, okay? All right. Let me keep going, just Solomon, because the video is going. I'm going to keep going, but I will come back to you and see what happened with that and why we got a different answer, okay? All right, let's do the last example. And here it wants you to find a polynomial equation satisfying the given conditions. If there is no such equation, say so. All right, so it tells you that something has roots of negative 1, 4, and 5. So how could I write that as a polynomial? Well, could I write each of these as a factor first? So what would be the factor that negative 1 came from? X plus 1. What would be the factor that 4 came from? X minus 4. And then the factor would be x minus 5. Now, if they ask you to leave it in factored form, that's fine. But usually if they're asking you for a polynomial, then they're going to want it in standard form. which means you just got to work that all out. That's not too bad. So go ahead and distribute it out. And then combine like terms. Check my work. And now it does say of the format f of x equals 0. So if that's the format they want it in, then we should write it in that format. Am I good? All right, try letter B. One of the factors is x minus 3. And negative 4 is a root of multiplicity 2. So one of the factors is x minus 3. What would the other factor have to be? X plus 4. And then since it's multiplicity 2, I would square it. Go ahead and work that out. All right, check my work. Again, kind of notice with these first two, the first one had 3 roots, and it's a cubic, third power, right? The second one also had 3 roots, because negative 4 was a double root, right? And it was also a cubic. Okay, so again, fundamental theorem of algebra is going to keep telling you a good way to sort of check your work here. Did I do it right? Am I good? You guys agree with me? Did I distribute, combine like terms, multiplied? All right, letter C. The degree of f is 4. The number negative 5 is a root of multiplicity 3. And 6 is a root of multiplicity 2. All right, so how would I do this? If it's a root of multiplicity 3, that would have to be what? X plus 5 to the third. And then 6, so that would be x minus 6, is a root of multiplicity 2.
What's the degree of 4?
What does the degree of 4 mean? This is an important piece.
Would that be x minus 4 in front of it?
Yeah, what would the degree of this equation have to be? Yeah, this would be a degree of 5 because you would add these together and you would end up getting a degree of 5 here, right? Because you technically have 5 roots, right? You've got one with a multiplicity of 3 and another one with a multiplicity of 2. So you have a degree of 5, but it said the degree is only 4. So is this a possible question? No, not possible. Okay, so sometimes they'll give you ones that are impossible, and that's it. Okay, again, degree, just by definition, if we forgot what a degree is your highest exponent. Look at that for timing. It's not really time to go yet. All right, that's the degree of time is a highest exponent. Let me come around and answer questions after I stop my video.